Okay. So we got the project open with all the layers that I previously loaded. Okay, let's close this and let's close this, and now we can rock and roll with this polymer. You can go 230, 40, 60,000 million years ago. Can go to 140 million years ago, and you can scroll all the way to today's date. And this is the layers, and you can play with the layers as well. Let's say we're talking about the drag marks pattern. So we can show the drag marks pattern over the paleo map. That's nice. And we can see the mid-ocean ridge in red. Here we go. We got the mid-ocean ridge in red is a layer. Let's see in the blue map. I like to see in the blue map. Here we go, the blue map, because the ocean floor is black and white, and nice contrast. And you can see the drag marks pattern. Those are huge mountain ranges all over the deep ocean floor, and they call it natural formation. For sure it has to be a natural formation. Natural is there, but I mean there is no study on this pattern. This is a very nice pattern, and you can notice those lines are mountain ranges, like 5 kilometers, 4 kilometers high mountain range that goes to 100 miles, 1,000 miles, and they tell something as a pattern that they are. They can tell you where Asia went. You can make the whole way of Asia just following this pattern. If you follow the pattern, you can see where Asia came from on Australia, and you also can see Australia from Antarctica, where Asia came from. Antarctica. Asia was previously here in Antarctica and went all the way up, and Australia also was previously here in Antarctica and went away. And you can see the exactly pattern showing the pattern showing the way that Australia did, and it's a very nice problem is like right here, when you have Asia going away, the mid-ocean ridge. Let's put the mid-ocean ridge on the top, so it shows. Here we go. It's on the top now. So the mid-ocean ridge is being crossed by this pattern of mountain ranges, and that's one of our points. How come Asia could cross over the center, the mid-ocean ridge, if everything was coming out from here? Actually, it's wrong. It can't be a mountain range crossing over this mid-ocean range freely in 3 points actually of this mid-ocean range. So it's very difficult to understand that. Well, anyhow, there is more into it. There is some 2,000 miles in between Asia tracks and Australia tracks, and we call that the ghost continents, the ghost tracks. It's other continents that they don't accounted for that move that way. At Malaysia and Laos region, you can see the ghost imprint here. Well, this is part of the boot camp. That's what we're going to study. If you guys like to, I'll be doing these lives more often. Let me take it off the ghost continents. Okay, tracks. Let me take it off the blue map. And now we got the paleo map. So in the paleo map, you can see that Asia and Australia were into Antarctica, right here. And there's pretty much nothing in between them. It's just Asia and Australia, and they go all the way up from Antarctica during these 100 million years or over 120 million years. So this gap is one of the problems that I see on the paleo map. Well, and also the fact that how come Asia made the tracks over the mid-ocean ridge? That's something else. I mean, all the books that you see, I'm gonna go to the storyboard here and find a picture that I used last time, and it's a very nice example. These are all the maps we have about the drag marks pattern, old earth crust, new earth crust, and the passive continental margins, and active continental margins, how they are related to the Pacific Ocean. And then, well, all the other maps we did. The standard map, G plates, the Pacific Center map is the one that we like to look for, understand better what happened here, and call attention to look into the Pacific Ocean, why it's there, and all the rings around, the ring of mountains, the ring of deep oceans, the deepest places in ocean. This I did myself. I tracked them up, so it's just a draft. Those others are academic stuff. The ring of volcanoes and how they go all the way to Antarctica as well. Here we go, another example. Well, anyhow, the pillars of the mantle, we're going to go over that too. And there's some sketches of this continental, the Pacific drop, and how the continents move around. Here's a little animation of the continents moving, and as they splash the water, large amount of water drop in the Pacific, taking off a big chunk of land with that, and depositing a lot of water, a fifth of the Earth's volume. It came on with that water. Anyhow, the storyboard is here, and in the storyboard I have a nice frame there that I like. Here we go, this frame here. In the geo books, history books, all over, when you see talking about the mid-ocean ridge, you see a drawing like this, the mid-ocean ridge, and these parallel lines, little mountains growing up out of the mid-ocean ridge. That's what makes sense. You got something in the center of the ocean spilling material, so you have little mountains, like forming according to the the surface. It's fine. But that's not what happened. What happened is here you have the mid-ocean ridge spilling mountain ranges sideways, like let me see, let me put the blue map on. Okay, the blue map on. Okay, so you have the mid-ocean ridge spilling these mountain ranges sideways, like instead they being here as vertical lines, they should be here as horizontal lines. You can see that not only on Asia and Antarctica, Asia tracks. You can see all over the ocean floor, whatever is mid-ocean ridges, even in the center, in a nice place where they are showing a lot more nice. They don't have too much of a confusion like Asia. Here is simple. South America is one side and Africa is in the other side, and in the middle there is the mountain ranges, and they cross the mid-ocean ridge. So nature it can do some exquisite things, but I don't believe they will make those lines so well. Those lines are huge formations. You can look at the ocean floor, you can follow with Google Maps, and you can look at NOAA. Those are NOAA maps. So, and also another thing, when you start to working with the maps, if you look at a regular map, so just to close this subject, I don't understand why all the books, every impression you see, you're going to see these lines parallel to the mid-ocean ridge. And they are wrong. They're supposed to be cutting across the mid-ocean ridge. That's what you see in the maps. So, case closed. And it's not on one, it's all of them. Because it's what makes sense. It does make sense that way. What does not make sense is this. This does not make sense, how they cross the mid-ocean bridge. Okay. No, we do make sense out of them, but not in the way they are taken. Well, so where were we? Mid-ocean bridge. Oh, okay. The maps. When you look at the regular map, here we go. Bedrock map from NOAA. You not see the edges. Here we go. All you're gonna see is a dull edge on the continent. Is the drag marks pattern just are evident in the center, and in the sides of the continents they not so evident. That's because we had to overlay the bedrock map with the gravity map to get these impressions, but they are there. They are there. And another thing that amazed me is like they are there, and they are 120, 130, 140 million years old at the edges. And they look the same all through the way. So I believe something could happen, some meteor or they will lose some for the erosion. The ocean currents are curly and they curl on the top of them. So that will call for a little erosion, and natural things could happen during 100 over million years. And it's not showing anything. They are perfect lying there, going from one continent to another continent, all the way leaving the marks. So that's a nice thing to see with G-plates. That's why we like to give you this tool and these maps so you can download from Earthbyte. They are very good at that. They have other maps also over there. You can see from History. Here we go, our maps. So most of these maps are from NOAA, almost all of them. We just work them out. And here you go, at the very bottom you see all the links for the Earthbyte.org, 3D map, G-plates portal, G-plates download, G-plates tutorials, and SCOTEBS, the paleomap link. So that's about it, I believe so, about the map. We're gonna do more work on that, but it's good that you have G-plates installed and your base kit that will be in the home page. Here we go. Ocean 4. This is the base kit, 80 megabytes, and in this you have the drag marks pattern. The drag marks pattern, the mid-ocean ridge, this blue map. Here we go, the drag marks pattern. This was just a scratch. We did a rough drawing for some of the drag marks. If you go and do a very well job here with more precise maps and some software, you see like this is just a very little part of what represent these mountain ranges. It's more like for us to follow up, but there's a lot of them that we did not get it. Most of them, I guess. It's just a drawing, a rough drawing, so we can understand their directions. And what else? What else we got here? Drag marks pattern, ghost continent shadows, and the mid-ocean ridge. Okay, that's it. That's about it. Now, okay. We're gonna go to the two main pillars. Don't close, gotta change. Let's say don't close, and let's keep this down here if I gotta go back.